Suppose that for some strange reason, whatever reason, you have to make a double-ended queue. But you're given even further constraints. You're not allowed to use the linked list. You're not allowed to use any of the default Java library things that are pretty handy to use. You can't use any of those. The only thing you can use is a primitive array. So here's our list of tools. You have these, and you're allowed to maybe keep a few pointers here and there, as long as it's constant space. That's fine. So, suppose we have some sort of queue, and we have to represent it with some kind of ints. All right, I'm just saying it's size 4 for now. Let me also go ahead and label the indices here. And well, one way to do this is we just say anytime we have something, just stick it inside the frontmost unused area. So what that means is we're generally going to build this way. So the first item that comes in, suppose someone asks you to enqueue 1, 2, 3, and 4. You just stick it in order, 1, 2, 3, and 4. And then someone asks you to dequeue the items. So this was enqueue, this is dequeue. Dequeue, just dequeue one item. Okay, that's fine. We just, well, we had a front pointer here, and we had a back pointer right here. What we do is we just return the thing at the front, and then have front point to the next thing. So that's this right here. We're going to return 1, and then we're going to move front to the next guy. So this spot is just kind of an open parking spot. Nobody's using it anymore. Well, now, here's the hard situation. Someone asks you to enqueue 5. Well, crap, our stuff can't handle this. There's no spot right here. If this were a bigger array, then that'd be pretty cool. But it's not big. Okay, so we got 2 options. Number 1, give up. But we can't do that. We need to do this project. So option number 2, we can resize this array. Yeah, we can just resize it and then copy everything over, and then we'll have space right there for sure. Well, this solution is not so good, because whenever you resize an array, that's going to be pretty expensive. So anytime you run to the end of the queue, it's going to be pretty bad. If someone asks you to enqueue 1, and then you dequeue another one, and you keep enqueuing and dequeuing, you're actually going to have a lot of empty parking spaces. So later on, if you have some sort of big queue, what ends up happening is all these spots are going to be vacant, and then you only have something here. This is your first item here. This is pretty inefficient. So what can we do? We can have a smarter implementation. Enter the circular array. So a circular array actually is just a normal array. It's not even circular. The only reason we call it circular is because whenever you reach the end of the queue, let me go ahead and draw it over here. So this demarcates the difference, right? So this one was the old crappy one, and this one's the new spiffy one. So in the new one, what we do is anytime it gets filled up, we just run back to the front. All right, so what that means is if you had a 1, 2, 3, and 4, now we're going through the same situation. We enqueued 1, 2, 3, 4. We have to dequeue one of them. Oh, that's fine. We can just return 1 over here, and then we have to enqueue a 5th one. Well, what we do is instead of expanding or anything like that, we just stick it in here. Another way of seeing this is, let me redraw this array, but curled up sort of like a roly-poly. So what we can do here is something like this. This was 0, 1, 2, 3. This is still the same array. There's nothing different about this. This is still 0, 1, 2, 3. It's not bigger, it's not smaller, it's just kind of curled up for visual purposes. So suppose that you have this situation now. Now this is the real way it's implemented, and this is just the way that we're looking at it. If we want to enqueue 5 at this point, we just move it over here. This is the new parking spot. It's basically a recycled parking spot, but it doesn't matter to us as long as we can reference it. So as long as we have a front right here, and a back pointing to here, technically, anytime we want to enqueue, you just stick it to the end of back, and anytime you want to dequeue, you just pop off the front. And then you shift everything by rotating it this way. You notice that everything that we do, enqueuing and dequeuing, ends up moving pointers in this direction, whereas in the old one, we had to go this way. Well, this circular implementation means we get to reuse parking spaces, and that's why it's good. I guess now, just at this point, I'm done explaining everything, but let's just go through a quick example of if we had to enqueue a few more other things in a circular array. So let me give you a different circular array. Suppose that this one's just got a few more spots. I'm really just going to run through an example at this point. There's nothing new conceptually. So we're going to have a 0, 1, 2, 3, 4, 5, 6. Now you'll notice that there should be a break right here. I just didn't draw the break, it's no big deal. So suppose someone asks you to in-cue, let's say 1 and 2. That's fine. To in-cue the first 2 elements, you just go ahead and stick 1 and 2 right there. I'll give you a hint. Every time we in-cue things, it's going to be in sequential increasing order. That's fine. And then when we dequeue, we just pop off the front guy. So remove this guy. So forgot to mention, we always keep a front to the front guy, and we always keep a back to the back guy. And then anytime you want to dequeue, you just pop off the front and then make the pointer move in the clockwise direction. So now it's over here. And then if you want to dequeue, that's fine. You got it. Done. And then you want to in-cue some more stuff. That's fine. You just stick it here, 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 and here. Can you stick it here? Yep, it's still fine. Can you stick it here? Yeah, you could. So if you happen to in-cue a bunch of items, you had these items in-queued, and someone wanted you to in-queue 7, that's fine, you can handle that. Now, if someone asks you to in-queue 8, if you had the old array version, you can't do that, but now you can. And then this would be the break between the front and the back. So this is a full capacity circle queue. So that's how I would recommend that you implement a circle queue for your strange reason of why you want to make some kind of circle queue.